Good morning, students. A warm welcome to physics class today. We are continue the lesson, fourth chapter, laws of motion. Today we are going to discuss friction. The topic is friction. There are two kinds of friction. First of all, you have to know what is friction. Friction means simple as opposing force. Two body touches together and the surface of the two body is acting as electromagnetic interaction, that is called as a friction. So here the two types of friction we are seeing here: static friction, kinetic friction. See, it opposes the static motion. Starting of motion, static friction, the starting motion will be opposites, that is called as a static friction. And the kinetic friction, it opposes the relative motion of the object. So this is the two types of static and kinetic friction. Similarly, the second point, independent of surface area of contact. So the static friction is independent of surface area of contact. For kinetic friction, it is also independent of surface area of contact. So both the two is the same, only the difference is the starting motion and relative motion. Here we are denoted the coefficient of static friction is denoted mu s. Here the coefficient of kinetic friction denoted mu k. No need to see the everything. We are going to see the important topic as angle of friction. Look at here, angle of friction. Now the angle of friction is defined as the angle between the normal force N and the resultant force R. Look at the picture 3.28. Angle of friction may be understood using a block which is moving in right hand side direction. The force is acting in opposite direction according to Newton's third law. Both the two forces are equal and opposite. Here F denoted the force, forward direction force, and Fs denoted static friction, maximum static friction force, which takes place in opposite direction. You can look at the R. This R is the resultant force acting between normal and Fs. So normal means usually any object which is acting the force normally above direction. Look at the relation 3.32. This is the formula you can give here. Tan theta, which is equal to opposite by hypotenuse, that is opposite by adjacent. Opposite means Rn, so this Rn is equal to Fs, isn't it? This is the relation using for kinetic friction, the static friction for the angle of friction. Look at here, the relation may be identified as Fs maximum. Here Fs maximum means static friction maximum force, which is equal to mu s n. Mu s means just we have discussed coefficient of static friction. Here n is normal force. So what will coefficient of static friction? Mu s is equal to Fs maximum by n. So this may be written as mu s is equal to tan theta. So already we know here from relation 3.32 Fs by n, which is equal to tan theta. So here in 3.33 we can substitute the value of Fs by n, which is equal to tan theta. So the final relation will come mu s is equal to tan theta. So look at this, as you can see. This will be mu s is equal to tan theta, which is the final relation for coefficient of static friction, which is equal to angle of friction, that is angle of friction will be given here, the tan theta. Okay, now here next see angle of repose. What is angle of repose? Look at the diagram. So angle of repose can be understood using the inclined angle. So this is inclined angle sliding down, one of the body which is sliding down. So very simple, you can take the scale and put the rubber at the middle and you just increase the angle. If you keep on increase the angle, the rubber will not retain in the original position. The rubber will go in downward direction, whether left or right. That is called as a angle of repose. You can look at this small angle of theta. Angle theta is increased for a particular value of theta. The object becomes to slide down, so this value called as angle of repose. Look at the diagram. A body, yellow body, which is going slide in down direction. So this may be resolving in two components. One is horizontal components, another one is vertical components. Horizontal components is the mg sin theta, vertical component mg cos theta. Because the weight force takes place in downward direction, that is mg. This mg resolves in two components. So for the mg sin theta, which is opposite forces, friction force, Fs maximum. Now come to the relation here. From the first relation, n is equal to mg cos theta. So this n, which is equal to mg cos theta. So similarly you can see here the mg cos theta, which is coming from the components, horizontal components and vertical components. Here these vertical components will come as a static friction. Fs is equal to mu s n, as we discussed earlier. So mu s is equal to, from n we can substitute here mg cos theta. So what is Fs maximum, which is equal to mg sin theta. So mu s is equal to sin theta by cos theta. So we have to divide these two relation. So this and this relation, this is take as a first, this is take as a second. So both these two relation be divided here. What will come? Mu s is equal to sin theta by cos theta. Because mg will be cancelled, so what will come? Sin theta by cos theta will come. So mu s is equal to sin theta by cos theta. So what is mu s? That is we know about as a Fs by n, that we had discussed in kinetic friction, the angle of friction. So the final relation will come. We know about sin theta by cos theta tan theta, which is equal to as sin theta by cos theta. So this is the relation for uh, angle tan theta. So sin theta by cos theta, which is equal to tan theta. So this is the relation we have to understand here. So the final relation, as we received the same value as angle of friction. So the angle of friction, which is equal to angle of repose. So you can read this sentence. Thus the angle of repose is the same as the angle of friction, but the difference is that the angle of repose refers to inclined surface. So we have to understand this, the further relation as angle of repose and angle of friction will be equal by using this diagram. You have to understand. So this is very simple. Just to apply the trigonometric relation, simple trigonometric relation, and understand the static friction and the angle of the friction with respect to angle of repose. Okay, with this I have to conclude this using only one detailed questions in 11th physics, that chapter, laws of motion. We will see the next class as next important topics. Okay, thank you.